When we talk about artificial intelligence, it's often described as an artificial brain, a thinking machine. And while that comparison feels intuitive, it's also deeply misleading.
Viewing AI as an artificial brain completely shapes our expectations of what it can do and how it might fail. It sets up a flawed mental model right from the very beginning.
And this isn't just a philosophical thing. The assumption that we're building a machine that thinks like a person leads to some very real and often harmful conclusions about its capabilities, its reliability, and the risks it creates.
So to really understand the technology, we have to put the science fiction aside for a moment and look at the actual engineering goals. What problems are researchers really trying to solve here?
You see, the problem of creating intelligence was broken down by researchers into a set of smaller, more distinct problems. AI isn't one single pursuit, it's a whole collection of them.
This really shows you how computer scientists approach it. Instead of trying to build a whole mind, they build systems that simulate specific things, learning from data, perceiving the world through a camera, or processing human language. Each of these is its own incredibly complex field of study.
That leads us to the next critical question. The first attempts at AI tried to program rules for every single situation, but that just failed for most real-world problems. So, how does a modern system learn to identify an image or translate a sentence all on its own?
Well, the answer lies in a technique that has come to dominate the entire field: machine learning. The core idea is not about teaching a machine to think, but teaching it to recognize statistical patterns.
Machine learning algorithms are designed to just sift through enormous amounts of data and figure out the patterns within it. They aren't programmed with explicit knowledge about the world. They build their own statistical models from the examples they're shown. Now, this learning process generally happens in two main ways. With supervised learning, the system is trained on data that's already been labeled by humans. You can think of it like a photo album where every picture of a dog is tagged with the word dog. With unsupervised learning, the system gets a giant, unlabeled dataset and has to find the hidden structures all by itself. So at its core, modern AI takes in massive data sets, identifies statistical correlations in that data, and then uses that model to generate an output: a prediction, a sentence, a classification. But this total dependency on data creates a profound and completely unavoidable vulnerability. Because the system's entire understanding of the world comes from the data it's trained on, it will inevitably inherit every flaw, every gap, and every prejudice contained in that data. The system doesn't know what's fair or true, it only knows what is statistically common in its training set. This led to a well-documented incident where a photo service, which was trained on a data set with a severe lack of diversity, incorrectly and offensively labeled photos of Black individuals. And this wasn't a glitch in the way we usually think of it. The system was actually performing exactly as it was designed. It was just reflecting the skewed patterns in its training data. So algorithmic bias is not some unexpected bug. It is a direct and predictable consequence of the machine learning process. The system is a mirror, and it will reflect the society that created the data. This data inheritance problem is the source of many of the most significant risks that come with AI. These aren't hypothetical issues in the future. They are inherent to how today's systems function, and they are causing harm right now. All of these risks stem from that core design. Algorithmic bias reflects our past. Recommender systems learn that extreme content gets the most engagement, so they promote it, which helps misinformation spread. The statistical models inside these systems are often so complex that their decision-making process is a black box, even to their own developers. And of course, these powerful tools can be misused for things like surveillance or propaganda.
We've moved way past the point of asking whether AI can perform complex tasks. We already know it can. The central challenge for us now is no longer about capability, but about alignment and control. How do we build systems that not only achieve their goals, but do so in a way that is safe, fair, and fundamentally beneficial for all of us?